So let's talk about these three structures. Let's revisit them and determine whether they are aromatic, anti-aromatic, or non-aromatic. You will need to use the 4 criteria examined above every time you would like to do this exercise. So the only part where you will probably need a bit of help here is whether the structure is planar or not. But I will help you and tell you that after we're doing these examples, I will tell you or will give you guidance whether to assume a structure is planar or not. So let's begin right away. Number 1 criteria, if you go back up, it says the structure must be cyclic. So the question is cyclobutadiene, is it cyclic? Is it a ring? And the answer is yes, it is a ring. And this is also a ring. So all 3 of them are cyclic. I don't want to write too much because we don't want too much noise here. Okay, question or criterion number 2. Each atom in the ring must have an unhybridized p orbital. Well, if we have a pi bond, if we have a double bond, that means we do have conjugation. So in this case, yes, this is conjugated, and this is conjugated as well. You see a p orbital. Again, go back to chapter 16 and review that if you still need help. 3 is the structure planar? Structure must be planar to allow for continuous overlap of parallel p orbitals. And yes, this one is planar. We have 2 double bonds. And then they should be trigonal planar. We said for benzene, yes, they are planar. It's a planar molecule. But for cyclooctatetrene, if you recall from chapter 16, we said that this was not planar. It forms an envelope shape. Now, once again, I did promise you that I will help you with this because it could be complicated. So this is actually not planar. It folds like a tub shaped, and then there's no continuous overlap among the p orbitals. And then 4, does it satisfy Hewkel's rule? Or how many electrons it has? Well, let's look at, once again, over here. If we have 4n plus 2 pi electrons, or here, this number of pi electrons, then it should be aromatic. If it has the 4, 8, 12, 16, which is 4n pi electrons, then that would be anti-aromatic. So let me erase this and just look at that. So we have 2 pi bonds here. We already actually did solve this here for pi electrons. So each pi bond, so that's 2. And that's 2. So that's a total of 4 pi electrons. Now, so again, this doesn't satisfy Hewkel's rule. In fact, it satisfies the anti-aromatic rule. You can think of it that way. And this is now anti-aromatic. This is anti-aromatic, which explains why it is extremely unstable. We already talked about how this was found out to be extremely unstable. It's because it's anti-aromatic. As far as the hexane, we have 2 pi electrons, 2 pi, and 2 pi. So that's a total of 6. So does it satisfy Hewkel's rule? Yes, it does. So 6 pi electrons. So that comes out to be aromatic. Which has an unusual, as we said, stability. So, and then finally, this one right here, let's count the number of electrons. We do have 8, but so it doesn't satisfy Hewkel's rule, and it doesn't satisfy the whether it's planar or not. So this actually turns out to be non-aromatic. So it's neither aromatic nor anti-aromatic. And it turns out to be in the middle in terms of the stability. Between aromatic and anti. Okay, so let's examine aniline. Is it cyclic? Yes. Is it fully conjugated? Does it have p orbitals? Yes, it has pi bonds all over. Is it planar? Well, every single pi bond here gives the structure a trigonal planar. So I'm going to tell you that this is actually, yes, turns out to be that this is planar. And then, and there's enough space, then 4 is that, well, how many pi electrons does it have? Well, count them. There's 2 per each double bond or pi bond. So that turns out to be 2, 4, 6, 8, 10, 12, 14, 16, and 18. So the question is, does that follow the 4n plus 2 pi electrons? And let's go back up. We did the math already. Yes, it does. So that makes it aromatic. And that's why it's unusually stable despite how the huge structure that it possesses. Great. So when we come back in the next video, we'll talk now about charges or ionic cyclic polyenes. And then we'll also talk about heterocyclic compounds.